Hello, everyone. This is Professor Burns again, and here we are for your fourth lecture of the class, Lecture 1D, as in Delta. And we're going to go ahead and get started. So let me share my screen or share my screen with you all. And today we're going to pick up a little bit where we left off. So I want to do a review of pointers. Just give me a minute while I pull up the slides. All right, here we go. So let's do a review of pointers. This is where we left off in the last lecture. We'll also talk about arrays. We're going to do some code examples, and then we're going to go over input, right? Your file input. How do you get information from a file? And then finally, we'll talk about matrix allocation and how that applies to this class. So if you remember from last class, a pointer is simply a variable that points to a memory address. That's all it is. You're going to set that with the asterisk. We already know that it's going to point to a location of memory, and it's going to help us avoid making copies of variable. It also allows us to transfer information from one function to another by allowing functions that don't have access to that variable write into and receive information from the memory address that it's located at. Now, it adds one level of indirection, but that's actually okay because it allows us the flexibility of communicating between different functions. Now, there's terms that you will often hear sometimes in when we're using pointers as far as referencing and dereferencing. For reference, you're going to say that that's going to be set with the ampersand sign, and that is your actual variable that you want to get the information from. You're going to access that information, that memory information, with that ampersand, which meaning you're getting the data. You dereference the variable, meaning that I am not working directly with the variable, but I'm working with the pointer to it. So that's known as like a dereference. And you set that again with the asterisk sign, right? Ampersand, that's going to be your data, your memory. Your asterisk is going to be the address. All right. So now let's go a little bit into arrays. Now, we are all familiar with arrays. We use them often in our in a lot of programming languages. Is very essential because it's going to be this collection of information that allows me to get data, right? So your array is going to be in a collection of elements. Now, these elements are going to be of the same type. Now, there is a structure in C that allows us to get things or data type that allows us to do different types, but for arrays, they must be all of the same type. So all integers or all characters or all floating point values, the elements have to be of the same data type. And you must declare the size of that array in C. Now, here's our format for and syntax for how we declare those particular items. You're going to start off with telling the type of data type of array. Now, remember from the last time, I already told you guys, anytime you do something in C, you must declare what type of variable it is. Functions, what am I returning? Nothing, fine, it's a void. If I'm returning something, what data type is it returning? All my variables, I need to tell it what type it is. So this is an integer array, and you'll see this number here that denotes the size of the array, right? That's what you have in the brackets, followed by the equal sign, and then the actual elements that you have here in the braces. And then, of course, this is going to give you your data type name. Now, sometimes we can use the asterisk to denote or declare an array. And yes, it is the same thing as a pointer, but really an array, when you first declare it, it's going to be a pointer to a memory location. It's always going to point to the address of the first element in the array. So that's why we can kind of declare it with this pointer. So if we said integer int array 2, we can say it's just a variable with 2 integers. We can also set it like this and say that you're going to have whatever that first element in the array is. If you want to know a particular number or you want to get a value of that, you're going to just put whatever your A would be my let me actually clean this up. It should be ARR. So if I wanted to get the value in this array, I'm going to go ahead and say uh whatever is the number of the element I want to get. So it's at position 0, then it will give me that particular item. Your array position, just like a lot of other programs, that first element is going to start at position 0. All right. Now, if you'll notice that these two are noted in two different things, when I have this asterisk next to pointed to this array, it actually is automatically going to give you whatever that first element in the array is. So these two integers are actually doing the same thing. All right. Oh, before we start, a string is actually an array. There is not a string data type in C. A string for C is just an array of characters. For example, char name 4 is going to be an array with 4 characters. And this is going to be kind of our identification as like a string. All right, we talked about it enough. Let's go ahead and do it, right? Let's go ahead and do some of this coding. I'm going to log in. You guys have seen this already. And again, I'm going to work in iLabs 2. That worked out well for us last time, so why not continue with that? All right. As before, I'm going to go ahead and pull up our menu. We're going to open one terminal, enlarge it. I'm going to CD right into teaching CS211 2025. I'm going to make a directory for this one. This is going to be week 1D. All right, I have nothing in this. Okay, let me actually move back a little bit. I'm going to copy my make file from the previous week into this one. And then I'm going to go back into this directory. All right, so now you'll see I have this make file in there. Because I'm where I want it to be, I'm going to go ahead and open up my make file in this window. All right, so this is the same we left where we left off last week. That's exactly kind of where we're starting this week. Like I told you before, I already have this make file kind of made the way that I want. All I need to do as I do these examples is go ahead and change this, update it to whatever my name for the new file is going to be. All right. I'm going to clear my history here. Let's go ahead and call this array test.c. We're going to open it up in Nano. All right. So you guys already know the first thing we're going to do is include our libraries, include standard library. I'm going to include my input output. And then I'm going to have my main function here. I like to comment so I know what I'm doing. Okay. For our main function, we are typically going to return a value. So I'm not going to, usually for this class, it will be returning some sort of value. Okay. And as a note, I'm going to print out the type of program this is, print array practice. Okay. All right, so now I've set up my program, right? Did that relatively easily. Let's go ahead and save this, and let's also make sure we can make this guy. All right, I can see here from the first file that the name that the name that I gave this, I think was array test. Let's go ahead and save that. Yes, array test.c. All right, so I have done that. Let's go ahead and make this. And let's go ahead and print this. And look at that, print it out well. So that's our first step to the program. Now, what I want to do is I want to create an array um, and print out the results of that array to the screen um, one element at a time. All right. So, like I said before, we need to do is we're going to declare what type of array this is. I'm going to call this int r. I need to say the size it is. We're going to make this 4 elements long. And what we're going to include in this, my structure from the slides, remember, is going to have the braces, the brackets here, and then the braces here. So I'm going to do 1, 3, 4, and 10. Those are going to be my elements for the array. And now I'm going to set up a for loop so that I can print out each of these, the numbers of these array on a new line. So when we do for loops and different things like that, what we can do is your for loop is going to be set up like this. For, you have to tell it what's going to be inside. It's just like our regular function here. Inside of this, I have to determine what my pointer is. That's going to be, I'm going to make that equal to I. From I is equal to 0. I'm going to go ahead and make that until I is less than 4 in my counter. And then I'm going to just keep on incrementing that by 1, right? So this is going to be your standard for loop format for some sort of an integer value that tells you what your count is. And you got to tell what you're going to go up to. For this case, I know that my array size is 4. So I'm going to go ahead and set this up to 4. Oh, also, let me put some notes into kind of what I want to do. All right. So now I have this. I have the infrastructure start up for my for loop. Again, this is going to be, okay, what am I using as my counter to increment it? I know my size of it. And then I just increment each time I go down. All right. Inside of this, I'm going to say print f. So I'm going to say for each element, I want to know the location of the element, and then I want to know the value of the element. The elements at is now, keep in mind my D is holding the space for whatever value I'm going to use. %sign D means I'm going to have some sort of variable I'm associating these with. All right, the variable for my first one is going to be I, because I will tell me what position my element is at. And then this is going to be what I use for actually getting the value of that element. So what does this say? What is this telling us? That means that the element at position 0 or 1 or whatever my I integer is going to be this, and that's what it's going to print out to the screen, followed by a end of line character. All right, so let's see how well we did. Oh, I'm sorry. I had a period that should have been. Oh, it's a period, not a comma. Fix that really quickly. All right, so you guys saw that error. Okay, so that looked like that worked. Let's go ahead and execute it. And look at that. So that element that's at this position 0, 1, 2, 3, right? This should be identical to what I have for the for my array. Now let's say, what if I wanted to do these in reverse order? I could say that instead of me printing it out from the first one, I can just go ahead and do this from I minus if I wanted to print this out in reverse order, let me think about this for a minute so that I don't let's set up an integer. Okay. So if I want to get it from the original number, the original value, I can say I can start out with this. If I know already what my value is, I can say, okay, this is going to be 3. And if I want to print this out in reverse order, that means that the first element I'm going to be printing out is the last element of the array. So I can do this a few ways, right? I can set this up as whatever that last element of the array is. So it's going to be and each time I can decrement this. Or and then what I can do is now print this out in descending order. Now, there's a lot of ways you can do this. I could have just done the calculations inside here. I could have made it just say, okay, this is going to be whatever your 4 minus whatever that value is, minus I. This is just the way that I decided to do it. And now we should see this going in descending order. It's not going to do that way. So let's go ahead and do put the actual number in for calculations. Oh, you know what? Let's try it that way. All right, now this should print it out in descending order. Now keep in mind that because I want to actually do this each time the loop runs, my issue is that this actually needs to be inside of my for loop and not outside of it. So you copy that line, and each time we run it inside this for loop, we want to make sure that we copy those values. I'm going to get rid of it here, and that should resolve our other problem we had. And that exactly is what it does. So now I've just did 2 examples of this where I printed this first one in ascending order and then descending order. So if you had a similar problem, like if you're working with lists, how do I want to print this? How do I want to put it in ascending or descending order? That's one way to do it. All right. So now we have a good idea of this is how we work with arrays. Now, keep in mind that I said that anytime you are working with C, you have to know what data type you're using. And for arrays specifically, you need to know the size of the array. But what happens when we don't know the size of the array? What if I want to get some user input for the size and I do not know what that is? Well, then that gets into something called dynamic memory allocation. So before we do that example, let's kind of talk a little bit about what that means. Dynamic in dynamic memory allocation, the size of the data is not known. So typically if it's stationary data, I know like the array up there, all right, I know it was 4 elements long, but in the real world, you're not always going to know the size of it. You might be getting something from an input file or something from a user, and the size of it could vary from application to application or depending on what you're pulling from that from into your actual program. So what you need to do is you need to, when you run this program, you have to find a way to request or to get access to memory without knowing how large the size is going to be. And that's why this is called dynamic memory allocation. Now, the benefit of this is that it's going to promote flexibility. So now before I had to know the size of my array, I had to limit it to that particular size. Now, if I can do this dynamically, I can allow my programs to have varying memory data types and varying sizes for arrays, so I'm not limited by information I don't have. So what is Malloc, right? One way that you can do this specifically for arrays is by using this Malloc function. Now, what that stands for is memory allocation. So it is memory allocation for our arrays, or actually is memory allocation for various elements. We're going to use it in this case for arrays. Now, it's going to allocate a specific number of bytes to memory, right? So that's telling me that depending on the number of bytes each data type takes, if I know, once I determine the size of it, I'm going to include that number of bytes. I'm going to take out space for that number of bytes. And what Malloc is always going to return, similar to our pointer to the array, is a pointer to the first byte of where that memory was allocated. Now, anytime you allocate this memory, it's uninitialized. What does that mean? It means it doesn't have the information in there. It's not going to store it with some sort of value. It's going to be uninitialized. So let's look at kind of the basics of it. Allocates memories helps with dynamic variables. Now, your input parameters for this are going to be the type, meaning what is the data type, and the size. Yes, I know we don't know the size yet, but we have to put that in as a parameter in order to be able to dynamically allocate this information. Now, this has great applications and practical ways that we can use this is used for dynamic data. It can help you with things like lists and trees and arrays. We will talk about all of that at some point during this class, particularly like the lists and the trees. And it helps you to efficiently work with varying data sizes. All right, so you can efficiently work with these varying data sizes. Some of your common errors that you're going to see is that you have memory leaks from not freeing the memory. You won't be able to access the memory after it's freed, and you can have the incorrect size allocation, which causes a buffer overflow. And you might have another problem where you're not dynamically checking for the null. All right. So let's look at this Malloc structure. And we're going to go ahead and do an example of that. If I wanted to create this, here is my structure. Your Malloc is going to be, like I said, it's a pointer because it's always going to point to the first address, the memory address of the first element that you're using. So you have to have your variable name for the pointer. You're going to have the type. What is the type that you're using, right? What is your data type? And then your Malloc, that's going to be your function. And next, you're going to have the size of the element. So if I had this for an example, I know that I'm creating a Now, here's what I know. Right now, I do not know what the elements of the array are. So what I'm using the malloc function for is to give make space for an array of a certain size, right? So I'm giving it the size of the array, but what I don't know is the value of the elements in the array. So since I don't know the value of those elements, this is where I'm just going to allocate uninitialized space for the array. And for this particular instance, my array is the size of my array. It's 3 elements in size, which means uh I'm going to allocate 3 times whatever number of bytes are needed for each integer. If an integer is 8 bytes, that means that the size that I'm allocating is 3 times 8, which is going to be 8, 16, 24 bytes of total memory for this particular element here. Let's go ahead and do an example for this because that would help us understand it better. All right, so I am going to save this. I'm actually going to rename this. What do you want to call this? We're going to do Malloc tests. You are going to save it in a different name. And that means when I do my naming here, I'm going to change that to Malloc test. Save it here. Malloc practice. Let's make sure we got all of that right here. All right, and it did do that Malloc test. Let me see if I have that. Malloc practice, also awesome, excellent, excellent, excellent. All right, so let's go and say we did an example before where we were able to receive input from the user. Let's kind of build on that. All right, already said, cool, I have this array, but now I want to go a little bit further where I don't know what my size of the array is. Um, and or I don't know what the elements of my array are. I'm going to receive that from the user. So I had this structure kind of already there. Um, gonna get rid of this because I don't need it. I don't want this here. Da, 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 da. All right. All right, so here's what's happening. I'm just going back similar to what we had before, right? If I ran this, if I had an array like it was before, I knew all my elements, it would be in there, right? But thing is, I don't. We don't have that. So what we have to do is we have to declare that. We have to tell it what exactly are we putting into this data. All right. So now instead of my array being a being known, I'm going to use this malloc function in order to uh, allocate information for that. All right, so we're at a point now where we want to have an array here, and I'm actually going to remove this because I want to dynamically allocate the information for this array. This is what I had before. I knew the size of it. I knew what I wanted to input into it. Now I'm going to make this kind of a pointer, right? Because I don't know what the elements are they're going to go into this array, and I need to declare that somehow. And this is where our Malloc function comes in. So right here, I'm just setting up my dynamic variable here, this pointer. Now, what I'm going to do is I'm going to set up the information for this. Because I've already denoted that this is this kind of indicator here that's saying it's some sort of array, it's going to be a dynamic variable. In my second line here, where I'm going to implement the Malloc function, I don't need to put the asterisk again. Now, let's go back and look at our format for this. This is our format. You're going to have your pointer variable name. Then that's going to be followed by the data type followed by an asterisk, because I'm telling you that this is going to be a pointer to that particular data type. Next is going to be the Malloc, which is our function, the size of my array in this instance, and then what I want to, what type of variable I'm going to multiply that by. So let's go ahead and implement that. So I know my variable type is going to be an integer. All right, that's my variable type. Next, I'm going to have my Malloc. All right, for this one, I'm going to go ahead and make this size 3. Nah, I'll go ahead and make it 4. I'll make it 4. Times the size of the data type of the array. All right. I have just kind of allocated memory for my array. So let me go ahead and put that in the comments here. Dynamically allocate memory for the array. All right. So dynamic I dynamically allocated information for the array here. I'm going to actually delete this. Okay. Now the next thing I want to do is from my user, I want to get the values that are going inside of this array. All right. So we worked with this last time. We're going to use something, the scanf function. Oh, before we do that, let me go ahead and I want to use this program. I want to use this further down the line. So I'm going to go ahead and copy this, which according to my things here, it's going to be Alt-6. And then I'm going to use the Control-U option to paste that. Or Control-K, I'm going to use that to cut that information. We're going to copy it there and paste it there, just so I don't have to rewrite it twice. All right, here's going to be where I print the information to screen. And here is where I'm going to retrieve the information from the user. All right, so I've dynamically allocated my array here. Here's where I'm going to retrieve the information. And then at the end of that, down here is where I'm going to print the information to screen. What I'm also going to do is spell this correctly. Alrighty. I before E except after C. So that also needs to be changed. Okay. Now, before we had something, we had this function, this scanf function. So scanf will allow us to get the information we need from the user. And all I'm retrieving is just a integer value. So %D. I want to get an integer value from the user for as long as I have data available in this screen. Okay. And what I am retrieving or what I'm getting access to is I want to store that into my array at a specific spot. Now keep in mind that the user is inputting this data, but they do not have direct access to your variable inside. So I need to basically tell it to give that information or manipulate the memory in order to get that information. So I'm saying scanf, get this data from the user, and I'm going to store it into the address at the address of array element I. All right. Store the input for the user at the address for the array element I. All right. Now, once I do that and everything is kind of said and done, I'm ready, I'm all good, then I should be able to, once I retrieve the information, I should be able to then print this data to the screen. Let me just double check some things. For review, Malloc practice, I've declared my pointer here, my dynamic array. I allocated memory for this array. I know that this is going to be of type integer, so that's going to be my first element here. Malloc means I'm going to allocate memory. I'm allocating 4 times, meaning I'm going to have 4 elements of this array of size int. All right. So boom, I got this first information. Let's go ahead and see if we can compile this without error. No, this is telling me that I have some sort of error. Implicit declaration of the function size. Oh, I'm sorry. This should be size of, because that is the correct format. Looking back at our thing here, it should be size of. Let me go ahead and that's how this is denoted here. And let's see what the other error was. All right, so that should take care of both of them. I'm going to save this with the Control S. Okay, we successfully made that. Wonderful and fantastic. All right, now let's go ahead and run this. All right, so here's where we are inputting the information. So I'm going to make this 9, 0, 1, and 2. Okay, so let's ignore this for right now. We'll talk about that in a few. But look at what happened here. It said I input my information to the screen here, the elements for the array, and then it went ahead and it did execute the information where for each element of the array, it printed out the location of that, and then it also printed out the value within that, right? So that's working properly. Now, what we see here is that leak error. Now, if you guys remember, I talked about some of the common problems. Well, hold on. Let me just we're gonna come back to this. I know this is an issue. We're gonna come back to that. So we know that we have input dynamically the information that's going into this array, and we see that it has stored it successfully into this array function, because then I was able to print it out element by element to the particular screen. That means that that actually worked. I'm going to add a little bit of a comment here to the screen. So we can kind of see the user is inputting the array elements. Now, I'm also going to do something else here. This we talked about before. This potential error that you would see, we talked about in this class. You see how it says it has a leak sanitizer? I allocated this memory, but after I allocate it, I have to do something to get rid of that allocation, right? So let's look at what that is. That's going to be something called free. Your free function is used to deallocate memory. All right. So this thing with memory, because so many people have access to it, or so many processes have access to it, once you're done with it, you need to make sure that you free it up for other programs and applications to use. So when I use this free function, it allows me to deallocate that memory from the previous process so it can be freed up for other options. It should always be used after Malloc. If you do not use it, this is where you're going to come up with that error. Because you didn't free up the memory, which means that it could get corrupted. There's going to be leaks, and it will not be accessible or available to other programs that want to use it. Now, for this, all you're inputting to this is just your pointer variable. That's how it works. You say, hey, whatever my pointer variable is, once I'm done with it, I'm going to free it. So in our program, all we do to kind of fix that is at the end, I'm going to free this up. I'm going to say free ARR. I do not have to put, I can put the variable just like that. I don't need the asterisk because it's already expecting a pointer. So I can just free I can just say free without the asterisk symbol here in order to free my variable. Now we're going to go ahead and make this, and we're going to run it again. All right, now what you'll see now is I entered this for my sanity to understand what we were inputting into this actual function. Now when we run that, look at that, no errors. Why? Because now my memory is clean since I have deallocated it. All right, so like I said before, those are going to be your common errors that you see, right? This memory leak from not freeing the memory. What you'll also see is you might try to access this after you freed it. So now if I went back in and I tried to get the array information at a certain value, it wouldn't be there because it's already done. So I'll go ahead and show an example of that. Let's say now I freed it, and now I'm going to try to print out the data for that. What is and let's go ahead and include this. Now, if I try to access this array at 0, and I said, hey, I want to get this information, it's going to come up with an error. First error is that I did not spell this right. The hazards of working in multiple languages. All right, it's going to compile just fine because from the program perspective, everything looks great. But when I try to run it, watch what happens. Now, you're seeing quite a different error here. It executed these first few fine. It absolutely printed out my array. It printed out the information here. But now I'm getting a memory address sanitizer error that says heap after the free address is used. That means I'm trying to access this memory, this array information, once it's been deallocated. It is no longer available for my access. And now it's going to come and have all these errors. So when does this happen? This happens when, for example, you either deallocate memory or you're trying to access, you say my array size is 6 integers long, and I want to figure out what the array is at 7, at the integer 7. It's not available, so you're going to come out with this particular error, right? All right, so I'm going to just comment this out. We don't need that. All right, so that's one element. And finally, last but not least, let's go ahead. Now that we kind of have an understanding of the malloc and freeing memory. All right, I did that. So this is what you'll see when you go to class. I mean, when you pull down slides. Ooh, files. Yes. Now, we will be retrieving most of our information from files. So up to this point, I've been using the scanf function, which gets input directly from the user. But for most of our programs, for most of the code and things that we'll be doing, we're actually going to retrieve the information from files. So here are some of your common file functions and different things you might be using. Open a file, and notice how this is very similar. Like scanf, you're getting the information from the user. Fscan, it means you're getting the information from a file, right? That makes sense. Fprint is meaning you're printing the information from the file. And then, of course, fclose. So they're pretty self-explanatory. Now, here's your variable format for what you're going to be using. You're going to include your fscanf. That's going to be your function. You need to have your file, which is going to be your pointer, the format of what you're using, and then your variable output. So now keep in mind that, again, your file is going to be outside the scope of your function, right? It is going to be not going to be a direct like variable in your main function. So your file is actually going to be a pointer. It's going to be a pointer to an address so that you can pull the information from. It's outside of your program, which means you need a pointer to get the data from it. And then this is the type of data you're retrieving. And then, of course, what is your variable output? Where do you want to store this data at? All right, so let's go ahead and look at an example. Oh, file open. Here's your format for this. I want to open this file. This is my file name, and what I want to do is I want to read from it. So let's go and do an example, because why not? Let's do an example because, okay. I need to get some sleep. That's what I need to do. So, all right, I'm gonna resave this file as file test.c, which means I'm gonna update my make file to say file test.c. Let's go ahead and save that in my terminal. I'm gonna do I didn't want to do that. Let's in my terminal, I'm going to also say this is going to be file. I want to make sure that this properly executes. Yep. And then when I do the file out, this is my file practice. Cool. All right. So that's all done. Great. Wonderful. Now, instead of me pulling this from the user input, I want to first I'm going to declare my file. Okay. Now, once I declare my file, the next thing I need to do, I'm going to say declare your file information. File pointer. I need to open the file so that I can retrieve the information. Let's go ahead and do this all in one step. F open. And then I said that the format for this was file.txt, and we're going to go ahead and read that. So now I have my file pointer information. That's kind of what I'm reading. But right now, I'm going to directly read that. Let's set up something where we actually have a file input. And all right, I am going to go ahead and get this information from here. I've saved that. The next thing I want to do is, instead of having this guy, now this fscanf becomes F. Oof, wow. Scanf becomes fscanf. And what I need to have here is my f of p. Let's just go back. I want to make sure I have this correct. Yep, that's going to be my file pointer, the format, and then where I want to store this data. Yes. Yes, it is. That's exactly where I want to store this data. So we're going to go ahead and just try to run it and see what we get. And look at that. It worked. Beautiful. Let's go and look at our file, 35, 14, and 5. Bing, bang, got it. We're just about good. All right, there's one more thing I want to go over. I retrieved the information from this file, but if I did not have a standard value and I wanted to receive the input from the user as part of my function, I could do that. Right now, what's going into this main is nothing. It's empty. But I could, in fact, say, okay, I want to include data here. In which case, I would then say I have some arguments, right? If I want to get arguments here, this first one is going to tell me, it's going to be an integer that tells me, excuse me, that I have some sort of arguments that are being fed into this function. So that's always going to be what you have at the beginning, typically. And then you want to put whatever your input parameters are. Because I know this is going to be a file name, the double asterisk means that it is an array of varying size, right? It's a pointer to an array because I don't know the size or how big the file name is going to be. And then my variable. All right, so all I'm saying here is I just added this information here in order to get what my in order to get the file input from the user. So the next time I run this, I'm going to run it and actually request user input. All right. In addition to that, now I have to go ahead and change. Instead of me having this file txt here, I am now going to have this as my argument. I am now going to have, say, I'm now going to be pulling information in from my file, and I'm going to request that the user give me that data. So what does that look like when we run it? First of all, let's make it. So now when I run it, I need to give it an input. So remember when I ran it before, I gave it no input data. And now what I am giving it is this here to have my input file. And it does the same thing in terms of pulling that out of pulling that information out. I'm actually going to re-explain this. I'll go over that input and all of that a little bit more in the next class, just so it's a little bit more clear. But for today, that's pretty much what we did. So this is the program that we generated, and that's all that I have for you today. And the next lecture, we're going to go over how to do the struct format, and I'll also give a little bit more of uh, an explanation for how we input the file parameters as a parameter for the main line. All right. I hope to see you guys again in lecture 1E and enjoy the rest of your day.